We have seen that class A contains nearly 2 power 24, which is 16 million, and class B contains 2 power 16, which is 64,000, and class C, the smallest class, also contains 256 IP addresses, which means 254 hosts can be configured. In many of the cases in practical at industry, what happens is we don't want very big networks. The reason is maintenance will be very difficult. So if you see, let us say we have a class A network. So in class A network there are nearly 16 million hosts, right? So if I have 16 million hosts in one network, then for a network administrator, management of all these things is going to be, all these many hosts is going to be a headache, right? So first thing is, maintenance of a very big network is going to be really a headache. And second thing is, we want to provide some security within the network, within the same network. Let us say in your office, in your company, we have four departments, and one department is developers, and other department is testing, and other department is maintenance, and other is HR department. So we don't want all the departments to access any common servers. For example, if there is any code server, we want to protect this code server from the other departments, right? So in this case, we don't want to leave the network loosely. So one thing is, if I have a very big network, maintenance is going to be very difficult, and second thing is security is going to be one more second issue. That is why even we have a big network, we are going to divide into many smaller networks. This is called subnetting. Subnetting is nothing but dividing a big network into many small networks. Advantage is maintenance of smaller networks is easy compared to maintaining one big network, and second thing is we could provide security to some particular network from the other networks. Okay, and this is about the subnetting. Even subnetting is having some advantages, but it also gets along with it some disadvantages too. So disadvantages, first thing is, if you have a single network, one big network, in order to reach a host, we needed three steps. One is identification of the network, identification of the host, and then identification of the process. So in order to reach the process, there are only three steps required. But now if you have a subnetting, which means if we have a very big network which is divided into smaller networks, then the identification problem is complex, which means you have to reach the network first, and then you have to reach the subnet, and then you have to reach the host, and then you have to reach the process, right? Here we have 4 steps involved. In case of subnetting, here there are only 3 steps. So advantages are there as well as disadvantages are there, but then advantages are more prominent, and so we even go for subnetting. So I'll take an example and explain you how subnetting works. Let us say you bought a class C network, and a class C network, as you know, contains 8 bits in the host ID part, which means 256 IP addresses and 254 hosts, right? So let us say that this is a class C network, 200.1.2.0, that is the network ID, and this entire part is network ID, and this 8 bits is host ID. Now how many bits are the host ID in class C? It is generally 8 bits, right? So 8 bits are in the host ID part. 1, 2, 3, 4, 5, 6, 7, 8. So using 8 bits, how many parts can I divide how many IP addresses do I get? 2 power 8, which is 256. How many hosts can I configure? 2 power 8 minus 2, 254. Why? Because the first address is given as network ID and the last address is given as directed broadcast address. Therefore, these two IP addresses are generally not used, right? And in the remaining, we have 8 bits, right? So in these 8 bits, I would like to divide this entire 254 or 256 IP addresses into 2 parts. If I have to divide the number space into 2 parts, how many bits should we choose? 1 bit. So I am choosing the first bit among the 8 bits. If I choose 1 bit, we are actually dividing the entire number space into 2 halves. So the first half contains 1, 2, 3, 4, 5, 6, 7, 8. The first half contains 0, that is the starting bit, and the second half contains 1. 1, 2, 3, 4, 5, 6, 7, 8. Second half contains 1, right? Now, what about the 7 bits, the range? what is the range of IP addresses that fall in the first hop and what is the range of IP addresses that fall in the second hop. So if you look at the range of IP addresses that fall in the first hop, I have to start with all zeros, these 7 zeros, right? So the range is 0, 0, 0, 0, 0, 0, 0, 1, it is 1, 0, 0, 0, 0, 0, 1, 0, this is 2, so on, 1, 2, 3, 4, 1, 2, 3, this is 7 ones, which is nothing but 127. So the range of addresses in the first hop is 0 to 127. Now what about the range of addresses in the second hop? 0, 0, 0, 0, 0, 0, 0, 7 zeros, and moreover we have a 1 here. Therefore the first address is 128. Next one is 0, 0, 0, 0, 0, 0, 1. This is 129. So on, 1, 1, 1, 1, 1, 1, 1. So all 8 ones. Here 7 ones are there, already 1 is there. Therefore this is going to be 255. So in the first subnet the addresses are from 0 to 127, and in the second subnet the addresses are from 128 to 255. So always remember, see, previously what is the network ID? The network ID is 200.1.2. This is the network ID, and the remaining 8 bits were host ID, right? 1, 2, 3, 4, 5, 6, 7, 8. The remaining 8 bits were host ID, but then this bit is taken for subnet ID part, which means this bit is used to define the subnets. Since we have taken 1 bit, how many subnets we got? 2 subnets. And now the remaining part is the new host ID. Previously the host ID was completely 8 bits, but now one of the bit is given for subnet ID. Therefore the resulting host ID part is now containing only 7 bits, right? According to the definition of network ID, whenever I put all zeros in the host ID part, it is going to be the network ID, right? Therefore if I put all zeros in the host ID part, it is going to be the network ID for this network. So for this subnet, the subnet ID is nothing but 200.1.2.0, the first IP address. And now what about the last IP address, 200.1.2.127? This last IP address is always directed broadcast address for this particular subnet. Therefore this particular subnet's network ID is 200.1.2.0 and the directed broadcast address is 200.1.2.127. And what about this? The second subnet's network ID is always the first IP address, 200.1.2. What is the first IP address? 128. Why so? Because in the host ID part we have all zeros. And what about the directed broadcast address? It is nothing but the last address. What is the last address here? 200.1.2.255. Got it? So for the second subnet, this is the network ID and this is the directed broadcast address. For the first subnet, this is the network ID and this is the directed broadcast address. Now for the network as whole, this entire part is 200.1.2.0 is network ID and 200.1.255 is the directed broadcast address. So there is a confusion here. Whatever was the network ID of the first subnet, that number is also the network ID of the entire network, and whatever is the directed broadcast address of the last subnet, that is also the directed broadcast address of the entire network. There is a confusion, right? So now if I say 200.1.2.0, what do you think I mean? Do I mean that I am talking about the entire network or the first subnet? And second thing is, if I send out a packet with IP address 200.1.2.255, am I sending out that packet as a directed broadcast address to the entire network or only to the second subnet? That depends, right? In order to resolve this ambiguity, you have to see how they are actually arranged. See this? Whenever we do any subnetting, we get a router. This is called internal router, and your ISP is going to provide you internet connection from the external router, and now this is your internal router. Let us say this is one subnet and this is other subnet, and in this subnet you have addresses from 0 to 127, and in this subnet we have addresses from 128 to 255, and this is the network ID for this subnet, and this is the network ID for this subnet. 127 is the directed broadcast address for this subnet, and 255 is the directed broadcast address from this subnet. Now whenever I say .0, do I mean the entire network or only the first subnet? That depends on where you are standing. If you are inside the organization, then you know that the network is divided into two subnets. Then whenever you say 0, it means that you are actually talking about the subnet. If you are outside, then you are not aware that there are subnets inside the network. Therefore whenever you say 0, it means that you are talking about the entire network. That depends on the perspective, whether you are inside or you are outside. So if you are inside a network, okay, then you mean to talk about the subnets. If you are outside a network, you are talking about the entire network as a whole. Now if a packet is coming from within the network and if it has to be sent to .255, it means that it is the directed broadcast address to this network. If a packet is coming from outside network, which means if the packet is coming on this interface, okay, and now if the packet has to be sent to .255, then this router understands that that packet has to be broadcasted to the entire network. If a packet is coming from this interface and if the destination IP address is .255, then the router understands that that has to be sent only to this, right? And if a packet comes from this interface, if the destination IP address is 127, that the packet will be broadcasted only to this network, right? So depending on whether you are inside or outside, the actual IP addresses will be interpreted accordingly. Okay. Now one more question is, how many IP addresses are now usable here? So initially we had 256 IP addresses in class C. If you use them in a one single network, then total number of hosts you can configure is 254. Now whenever I do some this subnetting, now we got two subnets. Each subnet has 128 IP addresses, but then we will not be able to use all 128 IP addresses. We are going to use only 126 IP addresses. So overall we are not going to get 254 hosts, we are going to get only 252 hosts, which means because of subnetting there is even a loss in the number of IP addresses. The reason is every subnet is going to waste two IP addresses, one for the subnet ID as well as one for the directed broadcast address. Okay, so in order to divide this entire network into two subnets, we are choosing one bit and we got two subnets. Let us say I want to divide the entire network into 4 subnets. Then how many bits should I be choosing? If I want 4 parts, I have to choose 2 bits, right? So let me take the same example and explain you. Now I want to divide the entire network into 4 subnets. The entire class C network, the same one. 200.1.2.0 is a class C network and the host ID part contains 8 bits because it is class C. Now I want to divide into 4 parts. If I want to divide into 4 parts, then you have to take the 8 bits and then choose 2 bits among them. See, always in subnetting we are going to take the bits from the host ID part and we are going to choose some bits, right? So let me say I have chosen the first 2 bits, which means among 8 bits 1, 2, 3, 4, 5, 6, 7, 8. The entire number is 200.1.2. Among these 8 bits, I am going to choose first 2 bits. Depending on that, this first subnet, the S1, it is going to get 00 as subnet ID part. S2, it is going to get 01 as subnet ID part. S3, it is going to get 10 as subnet ID part, and S4 it is going to get 11 as the subnet ID part. So we have 4 subnets and each subnet has got these numbers, right? Now depending on this I want to find out the range. So what is the range of IP addresses that S1 will get, what is the range of IP addresses S2 will get, S3 will get, and S4 will get. Now if you look at the range of IP addresses S1 will get, so we have to leave 00 in the first 2 places, and in the remaining 6 bits we have to start with all zeros and go till all ones. So if I go with 6 zeros to 6 ones, the number is going to be, first number is going to be 0 and the last number is going to be 63. and in this one the first number is going to be 64 and the last number is going to be 127. In this one, first number is going to be 128 and last number is going to be 191, and here 192 to 255. Okay, so this is the range of IP addresses you get. So if you want to check it, you can just write the binary numbers and you can put all zeros to all ones, right? Therefore, what is the network ID of S1? Network ID of S1 is 0. What is the directed broadcast address for S1? It is 63. What is the network ID for S2? 64. What is the directed broadcast address for S2? It is 127. What is the network ID for S3? 192. What is the directed broadcast address for S3? 255. And same for S4, it is 128 and then 191. Okay. Now we know, as usual, we have wastage of 8 IP addresses. If it would have been just one single network, there would be only 2 IP addresses wasted. But since there are 4 networks, we have wasted nearly 8 IP addresses, right? Now the question is this: we have internal router which is connected to 4 networks and all the networks are connected with this. See this? Now even though this is the logical view, actual physical view is going to be like this. We have an internal router to which 4 networks are connected, and we have an external router. Okay. Now if any packet comes in to your network, which way should this router send it? See, the range of this first network is 0 to 63. The range of the second network is 64 to 127. Range of this third network is 128 to 191, and this network is 192 to 255. Now let us say we got a packet, and in this packet there is a message and there is source address and there is destination address, and now the destination address is saying that the packet has to be sent to 200.1.2.say20. Now the packet, they are saying that the packet has to be sent to 200.1.2.20. Now let us assume that this packet is arriving from this interface to this router. Okay, and now the packet has to be sent to 200.1.2.20, which means this network, right? Now this router has to forward it to this. Now how do you identify what is the interface that the router should choose in order to send a packet to that particular network, right? Which means you should identify what is the network that the particular host belongs to, which means given an IP address, you should identify what is the network ID of the network to which this IP address belongs. Okay, so for that purpose, one thing is you could manually see it and see the range of 0 to 63 and you can identify it. But then I want something which could be used at router in the software numbers so that it will be easier for the router to find out which way to send. So for that reason, we have a number called as subnet mask. Okay, I'll take an example and I'll explain you what is a subnet mask. So subnet mask. A subnet mask is again a 32-bit number. It contains 32 bits, right? 32 bits of zeros and ones, in which subnet mask contains ones and zeros, and the number of ones represent what is the network ID part and the subnet ID part, and the number of zeros represent what is the host ID part. That is what is the meaning of subnet mask. So subnet mask is a 32-bit number in which number of ones represent network ID part and subnet ID part, and number of zeros represent host ID part, right? So let us say for this example, for this one, 200.1.2.0, 200.1.2.0, what is the network ID part? Network ID part is 24 bits. And what is the host ID part? Host ID part is 8 bits, which means I have 8 bits, 8 bits, 8 bits, 8 bits. In this IP address, network ID part is the first 24 bits and the subnet ID part is the first 2 bits in the host ID part, isn't it? Therefore, in subnet mask, the ones has to be representing network ID part and the subnet ID part. So, the subnet mask for this subnetting is going to contain all ones in the first 24 bits. So, 1, 2, 3, 4, 5, 6, 7, 8. So 24 bits is going to be ones because they represent the network ID, and then in the host ID part we have chosen 2 bits for the subnetting, right? Therefore, in the host ID part 2 bits are going to be ones because we have chosen 2 bits to be the subnet ID part, and how many bits are remaining? 6 bits. Those 6 bits are going to be zeros. 1, 2, 3, 4, 5, 6, right? So if you see this, now the subnet mask for this subnetting is 24 bits of network ID plus 2 bits of subnet ID plus 6 bits of host ID part. So in the host ID part we are always going to get 0. Now this is nothing but the subnet ID, subnet mask. Now if you want to convert it into dotted decimal number system, it is nothing but 255.255.255.192. So this is the dotted decimal number system, dotted decimal representation of the subnet mask. Now what is the main advantage of subnet mask is, given any IP address, if you take the subnet mask and if you AND it, bitwise AND it, then you are going to get as output the network ID of the network to which this particular IP address belongs to. For example, in this example, let us say I got a packet whose IP address is 200.1.2.130, which means I want to send a packet to the host 200.1.2.130. Then I have to find out what is the network in which this particular host belongs to. For that I am going to use the subnet mask. So first step is convert the entire subnet, this a network ID, this IP address, into bits, zeros and ones. So what is 200? 200 is 192 plus 8. So 200 is this, 11 is 192, 0, 0, 1, 0, 0, 0, right? So this is 200. Now 200 dot 1 is 1, 2, 3, 4, 5, 6, 7 followed by 1, 2. 2 is 1, 2, 3, 4, 5, 6, 1, 0 dot. Now it is 130. 130 is nothing but 128 plus 2. 128, 1, 2, 3, 4, 5 plus 2. Okay. So this is nothing but 200.1.2.130, and this is the subnet mask. So what did I do? Now I have given an IP address. This is the subnet mask and this is the IP address. Given an IP address, I have taken the subnet mask and IP address in binary form, and now I apply bitwise ANDing. I'll take this respective bits and I just AND them, bitwise AND them. What is 1 and 1? 1. What is 1 and 1? 1. 1 and 0? 0. 1 and 0? 0. 1 and 1? 1. 0, 0, 0. Which means I got 200 as it is. So whenever you AND any number with 255, you get the same number. Since you are ANDing 200 with 255, you get 200. From next time we are not going to do this. Okay, remember this. Now what about this one? 0, 0, 0, 0, 0, 0, 0, 1, which is nothing but 200.1 dot. What about this one? 0, 0, 0, 0, 0, 0, 1, 0, which is nothing but 2 dot. What about this one? If I AND it, 1 and 1 is 1, 1 and 1 is 1, and 1 and 0 is 0, 0, 0, 0, 0, 0, 0, which is nothing but 128. So observe this. So given this IP address 200.1.2.130, I got the output as 200.1.2.128, which means that the IP address 200.1.2.130 belongs to the network 200.1.2.128, which is nothing but. So from this you should understand that given an IP address and a subnet mask, we can find out the network ID of the network to which the IP address belongs to. If you want to check one more example, say subnet mask is, what is subnet mask for this? The subnet mask for this is 255.255.255.192, and if I take an IP address, let us say 200.1.2.10, then what is the output I get? 200.1.2. What is 192 if I AND it with 10? If I AND 192 and 10, 10 is nothing but 0 0 0 0 1 0 1 0, right? So if I AND 192 and 10, I am going to get 0, which is nothing but this is the network ID to which this IP address belongs to, which is nothing but dot 10 belongs to the network dot 0. So dot 10 here belongs to the network dot 0. That is what is the meaning of this, right? So using subnet mask, we can find out the network ID of the network to which some particular IP address belongs to, right? Therefore this router will use the subnet mask in order to find out what is the interface it should forward the packet to. So for that process, it is going to make use of something called as routing table. So routing table using subnet mask is going to look something like this. Say we have all these four subnets, and this subnet ID, this one, the interface of this is A, interface of this one is B, interface of this one is C, interface of this one is D, and this interface is E. Okay, so now we have to look at the IP address of an incoming packet, and we should decide about which way we should forward it. That is the main intention of the routing table. Therefore routing table is going to contain what is the network ID, okay, and what is the subnet mask, and what is the interface. So whenever any packet comes in, we are going to take the subnet mask and the destination IP address, and if the output matches with this network ID, we are going to send it through this interface. If it doesn't match, we go to the next one. For example, how many networks do we have here? In this case, we have 4 networks. What are the network IDs of all the 4 networks? 200.1.2.0 is one network ID. And what about the second one? 200.1.2.64 is the second network ID. And next one is 200.1.2.128 is the next network ID. 200.1.2.192 is the next network ID. Therefore, we have 4 networks of these network IDs. Then what about the subnet mask? In this case, remember that whenever the sizes of the networks are same, it is also called as fixed length subnet masking. So in this case, the subnet mask for all the networks will be same. What is the subnet mask? Is the same one, 255.255.255.192. Subnet mask is going to be same for all the 4 networks. What is the interface to which dot 0 is connected? A. Interface to which dot 64 is connected? B. Interface to which dot 128 is connected? C. Interface to which dot 192 is connected? D. Okay. So what is the meaning of this routing table is, whenever we get any incoming packet, let us say with destination IP address 200.1.2.3, whenever router receives any packet, it will look at the destination IP address and then it will use the subnet mask and AND it. If the result matches with the network ID, then it will send the packet over that interface. If it doesn't match, it will go to next entry. If it doesn't match, it will go to next entry. Doesn't match, next entry. If all of the entries doesn't match, it means that the requested packet or the packet which we got doesn't belong to any of these networks. It has to be sent out. That is also sometimes called as default entry. If it doesn't match, then we are going to have a default entry 0.0.0.0 0.0.0.0. The significance of all zeros is, whenever you AND any IP address with all zeros, the output is definitely going to be all zeros. Therefore, if it doesn't match with all these entries, it will definitely match with this one, the all zeros. So we are going to send it as default entry, right? So while processing this routing table, you have to keep three things in mind. First thing is, if there is exactly one match, we could send the packet over that match. Sometimes, I'll show you later, there could be more than one matches, which means your packet can match with maybe one and then this one also. In this example it is not possible, but there could be some examples in which in your routing table your packet matches with two entries, not the default, the non-default entries only. Your packet might match with two entries. In that case, choose the interface which has the longest subnet mask. Longest subnet mask means whichever is the having more number of ones. You have to choose the subnet mask with that and send it over that. So first thing is, if there is exactly one match, use it. Second thing is, if there is more than one match, use the one with the longest run of ones. And third thing is, if it doesn't match with anything, then you can always go with the default entry. Okay, so I'll show you some other examples of subnetting with different sizes next.